Okay, let's say we have a set of data and we want to try to organize it in some way so we can understand the pattern of results. One way we could do it is through what's called a frequency distribution. So it's a tabulation of the number of individuals or scores that you have in each category of your measurement. And a frequency distribution could be displayed in a table or a graph. It can also be what we call grouped or ungrouped. It's basically a way for us to see at a glance how the scores are distributed. Are they high? Are they low? Where do they bunch up? And I want you to think of it as sort of a tally of your scores. So let's look at an example. Here we have some data. Let's imagine this is a class of 20 first-year students, and we asked them how many times they went out last week. So let's say, for our purposes, going out to party. They went out after 6 p.m. for any purpose unrelated to academic work. Now, when we're looking at the set of scores, it's a fairly small set of scores, so we can see that, yeah, there's an individual here who didn't go out at all. There's an individual who went out every night last week, but it's hard for us to really get a sense of the shape of that distribution. Now, if you imagine if this is more than 20 scores, if this is 100 scores or 200 scores, it could be even more difficult to try to discern what any patterns are. So one way we could begin to look at how to organize this information is through what we call the ungrouped frequency distribution. This is the simplest one, so let's start with that one. So here are our data again, and the way we would organize it is we would start with the most or the highest value and go all the way down to the lowest. So I'm going from 7 all the way down to 0, and I'm not skipping any numbers. This is the maximum number of nights out, and this is the minimum number of nights out. And then I'm just going to go through and tally the number of individuals who said they went out that particular number of times. So for 7, we had one individual who went out 7 times. For 6, I see that there are 2 individuals. For 5, also 2. For 4, there were actually 5 people who went out 4 times, 3 who went out 3 times, 4 who went out twice, 2 who went out once, and 1 who went out no times last week. So this is just a basic ungrouped frequency distribution. So now I can start to get a sense of where the scores are piling up. So a couple of things that you want to make note of. Again, you want to start from your highest and go to your lowest. And if the range of the values you're dealing with is fewer than 10, in this case we have 8 values listed, then an ungrouped table is perfectly sufficient. If you're starting to get more than 10, you may want to move into what we call a grouped frequency distribution table. We'll get to that in a minute. But here we have fewer than 10, so we're going to do an ungrouped frequency distribution. Our goal is to have about 7 to 10 categories. That's a good set of numbers to work with. Now, you don't have to stretch it out to get 7 if there are only 3 or 4. But typically, if you can break it into groups, 7 to 10 is a great goal to have. And you're going to make a column for all of the scores that you have, and then a column that represents your frequencies, or the number, the tally of those scores. And you're going to include all of the scores, even if there are none. So for example, if there were no individuals who went out one night last week, we would just put a 0 here where you see the 2, and we would not skip that category. We would keep it in the range there. The other thing that you want to note about how to interpret some of the information in here is the sum of the frequencies. So if we were to tally all of these numbers, we would actually get the total number of scores. So the sum of F is simply just the total, in this case, since these are students, the total number of students. So if we've constructed our frequency distribution correctly, if we add all of these up, we should get back to the original data set, which was 20. The sum of X, however, is a little bit different. The sum of X, you can think of that as the total number of nights out in this sample of 20 students. So if we were to add all of these numbers up, we would get the sum of X. So that's easy to do. If you have this 20 set of scores, you could just add them up. But what if you actually started with the distribution table? How do you get the sum of X? Well, that's fairly simple. You would just say this would be 7 nights out for this individual, so that's 7. 2 people who went out 6 times, that's 12. 2 people who went out 5 times, that's 10. 5 people who went out 4 times, and so on down the list. And you would total all of this up to get the sum of x. So this would actually represent the total number of nights out and should equal the total of this set of data. All right, here's my analogy for the frequency distribution table. If you have a receipt, the items that you've actually purchased are your X values. So you might have 5 to 10 different things that you've purchased, and those get listed here under the description. That's your X, your actual observations. Your f of x, the frequency of those, is the quantity. So how many of those items did you purchase? And then if you wanted to look at sums, you could actually just sum the quantity, and that would tell you the total number of scores that you have in the data set. And if you wanted to actually do what I was talking about, where you multiply the frequency times the items, that would actually get you the sum of all the scores. So the grouped frequency distribution is useful when you take the highest score and the lowest score, subtract them, and you find that there are more than 10. Then you might want to move into what we call a group frequency distribution. So putting the scores into intervals. So each interval then will be a category, and then you will again tally the scores. So let's take an example here. Let's say I have some grade data. These are grades for an exam. And here you see that the minimum, I've taken a little bit of the hard work out and have organized it by the lowest to the highest score, so you don't have to actually spot it in the lineup. But the minimum is 30 and the maximum is 100. So if I subtract those two, I'm going to get 70. Listing 70 different values and the frequency with which they occur is not going to be a very good way to summarize this information. So we probably want to condense it a little bit, and that's what I mean by making a grouped frequency distribution. So when we make groups or intervals, we want to again keep that rule of thumb in mind of about 7 to 10 categories. And we're going to do the same thing that we did with the ungrouped frequency distribution. Again, this is a slightly larger data set, so it might be difficult for us to discern, but you can see that there are a few low scores, mostly high scores, but if we had twice as much data, 4 times, 6 times as much data, it might be more difficult to discern, especially given that this is in order. It's a little bit easier to see that. But the grouped frequency distribution will allow us to look at it more quickly at a glance and see how the scores are distributed. So I'm going to take those same set of data and I'm going to organize it in a grouped frequency distribution. So I've now made categories in the column X, and each category is an interval, 30 to 39, 40 to 49, 50 to 59. In this case, I took the highest and the lowest, I subtracted them and decided that a 10-point scale seems reasonable to give me a number of categories. In this case, 1, 2, 3, 4, 5, 6, 7, 8. I'm between 7 to 10, and it's not an awkward number. If I divided by 10, it could be that I have intervals that are maybe by scores of 8, and that's not really, it seems more intuitive to think about it in these scores of 10. So the other thing to note about this grouped frequency distribution is that, again, no categories are skipped between the minimum and the maximum, even though there are categories where we don't see any observed scores, so they're still there as placeholders. The other thing that you want to note is that each category is inclusive and exhaustive. So every score between 30 and 109 in this case could be represented in this and not duplicated. So one begins with 30 to 39, and then we start the next with 40 to 49. We don't have any overlap between these, so there's no ambiguity about where the scores should fall when you look through the list. So this is, again, taking that information that we had in the previous slide and organizing it in a way that we can more quickly see that a lot of people did pretty well on this exam. There were a couple of individuals who did not, but on the whole, the scores were pretty good. So the group frequency distribution can be really handy in allowing us to see at a glance how the set of scores behaves. Just a couple of things to reiterate. Rules of thumb when you are deciding what type of distribution, or a grouped or an ungrouped. If you have more than 10 categories, you want to move to a grouped frequency distribution, and you want to aim for about 7 to 10 intervals. Not a hard and fast rule, but a good rule of thumb. There are exceptions to this rule. when you want to maybe display, say, time or money, there may be intervals that make more sense. So for time, maybe 5-second intervals make sense, or 10-second intervals make sense, or 60-minute intervals make sense. So keep that in mind as you're constructing. You want to use something that might be easier for people to interpret. And also to think about making sure that you don't make some of the common mistakes that we typically see with the frequency distribution table. And that is, again, failing to include categories where there may be no observed data. So skipping over those categories, you don't want to do that. You absolutely want to have a placeholder in there for those. And then also the thing that we typically see, people not actually making these categories mutually exclusive and exhaustive. So again, no overlap between these two. It's not 30 to 40 and then 40 to 50 and then 50 to 60 and so on. The scores will fit in only one category and no other category, and it's exhaustive. If you have scores between 30 and 109, a score will fit somewhere in this grouped frequency distribution. Okay, let's take a little quiz and see if we understand the basics of constructing a frequency distribution table and a group frequency distribution table. And in the next video, you'll learn a little bit more about some of the things you can add to a frequency distribution table.